The key to being successful in problem number 1 is knowing how to adjust your viewing window on your calculator. It says the projectile is thrown upwards, so its distance above the ground after t seconds is given to be the equation. So you have to type it in, negative 15 t squared. Now, on our calculator, we don't have a t, so our independent variable is our x. So the x on the calculator represents the t time on the for the problem here in number 1. So negative 15 x squared plus 480x. And there's a couple things you can do to, first of all, it's going to ask here, after how many seconds does it reach its maximum height, and what is the maximum height? Well, like I was going to say here, there's a couple things you can do that will help you figure out how to adjust your viewing window. But if you limited yourself to just the standard viewing window, that would go from negative 10 to 10 and in both directions. If you did that, I'm typing this in instead of hitting zoom 6 because I want my x-res to be 3. And if I hit graph, that's what the graph looks like. But we know that this function is a quadratic function, and we should know that because something is going up into the air and then it's gonna come back down. So if we type in t equals 0, we should see that, or we just plug in t equals 0, at time 0, the height is 0. And then when things go up in the air, they go up and then they come down. So we understand that. It would have a place where it lands. But what we're really looking for here is we're looking for the vertex of this parabola. And the vertex is easy to find once we can see the vertex. So that's the hard part. What I would suggest, like I said, there's a couple different ways to do this. If you went ahead and traced, just push the trace button. Remember, we already know that when x is 0, y is 0, or on the paper, when t is 0, the h is 0. So the h on our calculator, the x on our calculator represents the time, and the y on our calculator represents the height. So if we just hit the right arrow now, we can get an idea of the different coordinates of the points on this curve. So if we know the coordinates of the points on the curve, then we could adjust our window to see the curve. Because right now we can't see it. All we see is just a kind of a vertical looking line. But if we hit the right arrow, notice what the y coordinate just did. At t equals 0.45 seconds, the projectile is 215. It doesn't even say if it's feet or whatever. It doesn't say feet at all. So we'll assume feet. It's 215 feet in the air, and then goes to 423, 626, 823. So if you keep hitting the right arrow, the y values you can see are climbing pretty rapidly up in the neighborhood of now past 3,000. At the 10-second mark, the y values are 3,300 feet high or 3,300 whatever. And I'm going to keep going until I can see them coming back down. 38, keep going to the right. So this is one, now they're starting to come back down. So it looks like a maximum y value of around 3,800 or 3,900, something like that. And that's what happens when x is equal to 15. So if it takes about 15 seconds to get to the max height, then it's going to take about 15 seconds to get back down. So I can go to my window now. I can adjust my x min to 0 because x represents time. And then my x max, I'll go past 30 because I'm assuming it's going to take about 30 seconds to get back down. So I'll go maybe 35 for an x max. And remember, it was 3,800, about 3,800 for the y value, the maximum height. And so the maximum height, I have to increase my y max to, 4,000, let's say. And then I hit graph. And there we get to see the graph. And now, once we can see our vertex, then we do second trace. We're going to go ahead and hit maximum, and then move the cursor to the left of the maximum, mark it with an enter, then move the cursor to the right, mark it with an enter, and then back to the left a little bit. And we have our maximum at when x is 16, y is 3,840. So that's nice. They're nice round numbers. 16, 3,840. And so now we can answer the question. After how many seconds does it reach its maximum height? Therefore, after 16 seconds, because the number of seconds it takes to reach its maximum height is the x-coordinate of the vertex. So that's that part. And then the other part is, what is the max height? The max height is 3,840 units. We don't know what the units are, so we're just going to say 3,840 units. Probably feet, but we don't know. So after 16 seconds, it reaches its max height. So that's max height after 16 seconds. And that is how you do it. Now, I did mention there's some other ways to find the window. And the other ways that I would mention is just kind of guess and check. If I check 20 seconds, let's say, and at first guess, I think when I did this earlier, I checked 1,000 as a max, and then I get that. So again, just checking, maybe 2,500, just guessing and checking. I can see it's going to kind of go out like this. So I need to increase my x, and I can increase my x to 30, and then it has to go higher than that, so maybe 3,500. And I just keep doing that. Oh, so I need to go up a little higher and over a little bit more. But actually, when I only need to know the vertex, I don't need to go over to the right anymore. So I would just go up. So this is the guess and check method, maybe 4,500. And there. And if you had guessed, just to keep in mind, if you had guessed 10,000, it's not the end of the world, because you can still find a vertex at that. And if you had guessed x equals 100, again, not the end of the world. You could still calculate the maximum, left bound 1, right bound, let's say 25, and then guess back there, and you still get 16, 3,840.